Welcome, everybody, to the 2012 Distinguished Faculty Award Lecture. For those that may not know, this is a Senate award. We have 3 of them: the Distinguished Faculty Award, the Parker Award, and the Exceptional Adjunct Award. Now, the Distinguished Faculty Award is given to the individual who has distinguished themselves in the classroom and outside the classroom with various things that they've done with programs or other things that they have innovated here on the campus. Now, this year's award winner is Gerard.
Thank you, guys. Thank you. I think I'm supposed to sit down now. Stand up.
And every year, the Senate presents to the distinguished faculty member a plaque.
Oh, wow.
Nice little plaque.
Ooh, that's pretty. Congratulations. Thank you. Thank you, Mike. Ooh, that's pretty. Thank you.
And now I'll turn the time over to...
Wait, you're not done.
What am I...
Put on your magic medallion. You come on.
Oh, I'm supposed to do that? I thought you were going to do that. Oh, yes.
I like this format.
And those that are distinguished faculty members receive a medallion at graduation, usually at graduation.
I need that now.
This to you too.
Oh, thank you. Oh, yeah, thank you. That's my name. Thank you, guys.
You're welcome.
Thank you.
And we have one more presentation. We'll turn the time over to Monette Tiernan, who will introduce.
Monette.
Want to stay here?
Oh,
should stay
see,
here.
I keep trying to sit down. Yeah. I think I can't.
Good afternoon, and welcome again to the Distinguished Faculty Lecture Award Lecture. Since Kendi first received this award earlier in the year, I've learned that she immensely dislikes public praise. And that, in fact, she was terribly embarrassed in the halls of AD last June, having to listen to all the wonderful things that people had to say about her. So I decided to do something a little different by way of introducing Kendi this time. Dig around in those dark little closets for some real insight.
You've been talking to my husband.
Dish the dirt a little, just so you'd feel a little more comfortable.
Oh, I'm more at ease with that.
Well, sorry. Weeks and weeks and weeks I spent doing this, day and
how
night, day
cute.
and night, and nothing very juicy.
Don't you say anything.
I did find out that as a kid, she never ever ate her vegetables. And so if she starts lecturing
My mom didn't give you
about nutrition and how important it is for stroke, you can kind of take it with a grain of salt. You're just going to have to grin and bear the praiseful remarks once more.
Thank you.
Most of you know that Professor Gerard has been teaching at GCC for 37 years and has taught a wide range of courses: biology, evolution, physiology, human anatomy. Exceptionally committed to her students, to her colleagues, and to the college community at large. She served as chair of the biology division, as an academic senator, chair of the academic rank committee, and mentor to countless master's science students. Many of us know her primarily through her public roles, but others have had the pleasure of coming to know Dr. Gerard more closely through their work with her as colleagues and students. So just a few personal reflections regarding Professor Gerard's work, as well as her much valued presence here at GCC. Here's what some faculty have to say: that after 35 years of teaching, or more, I think, Kendi remains as enthusiastic and motivated, as smiling and as energetic as she was at the very beginning. That's amazing to me, that energy part.
Thank you.
She's created endless original teaching materials and resources to help students succeed, including a whole series of educational videos on the skeletal, muscular, and nervous systems. She's written and been awarded numerous grants in support of the biology division. She's a generous and caring mentor to new faculty, especially, consistently forthcoming, they say, in her time and energy with them. She's uncommonly committed to her students, often staying with students for hours after lab periods have ended to ensure they comprehend the material. And as for her students, they're equally filled with respect and just plain gratitude, the ones I talked to, for having taken her classes. Some of the remarks they have made regarding Professor Gerard are as follows: that she has motivated me to seek a career beyond anything I could have ever imagined. Another student, she brings her subjects to life with her charisma and her good humor. She has energy and enthusiasm for what she teaches, and most importantly, says one student, she truly cares about her students, and that shows in the classroom every day. Professor Gerard has a true gift for teaching and for making learning feel fun. She's patient to answer every question, even in the crowded lecture hall. And finally, according to one student, the reason I'll continue to do well as a student is because of the strong foundation built in Professor Gerard's class. So for her energy, her collegiality, and her dedication to students and to Glendale College, join me in welcoming the new recipient.
Thank you.
Of the
Thank you, everybody. Thank you, Monette. Thank you, everybody, for coming. Boy, I've got my mom here, my husband, and all my good friends, present and past students. I wanted to thank first of all, I want to tell you this is an amazing honor. Totally amazing and totally unexpected. Deeply appreciated. I don't feel I deserve it more than anybody in this room, but thank you very much. I sure appreciate it. So thank you, Distinguished Faculty Award Committee. Thank you to the foundation, and because they actually awarded me a generous grant, and it's to be used for better teaching students, and I'm happy to use it for that purpose. I'd like to thank all the teachers that I've worked with for all these 37 years. It's been a wonderful experience. I can't imagine being anywhere but here. I'd like to thank my students present and past. I've got a few sprinkling of them here. Thank you for putting up with me, especially when I lecture all the way through the lab. I'd like to especially thank the biology division and Keith Conover first. This wouldn't be behind me if Keith didn't help me, because I'm very old-fashioned, so my heart attack, or I told him I hope I don't have a stroke over this talk. So thank you for the bottom of my heart, Keith, for all the technical assistance. Maria, too. And Lynn was my advisor. Lynn goes, how's the talk going? So it's going. Yeah. So, and I'd like to thank Javier Gago, who's back there with a broken leg because he broke it playing soccer with his son. He's the soccer coach. I'd like to thank Joe Beeman. I'd like to thank Rob. Where's Rob? Changed seats. For being a good buddy. Shelly Ty is our newest one. Thank you guys. You make coming to work just great. I have to say we have a division that gets along, and we enjoy working with each other. And every day, I don't know, we just hang out in the hallway. And it's not really a division meeting, but we could have a division meeting out there in the hallway. So thank you guys for making my life good here. I'd like to thank some extra people. Nona, Mary, and Naira. Nona's our admin assistant. Mary and Naira are lab technicians. They make my life better every day. Tom Reich, I don't think he's here. He's a buddy. I'd just like to mention him. Steve Marsden's always had my back. When I was division chair, he'd come in and he'd say, let the little stuff go. Let the little stuff go. Just keep the big picture. And he's also been trying to get me to retire, but I kind of didn't do it. And I'm glad, because I don't think I'd be standing here. Right? If I did, I wouldn't be. I'd like to thank some special friends. Kathy Tyner came all the way from San Diego. She used to work with in 1980. She was half chemistry, half biology, and then you went down to San Diego in 89. And she is now vice president of Southwestern College. Southwestern, and she drove up this morning. Thank you very much, Kathy. I'd like to take a note and notice and recognize, rather, Marianne Fell. Marianne got the adjunct award for biology. How many years ago, Marianne? 3 or 4, 5 or 6. Thank you for coming. My mom is here. Catherine Lamborn. She had 6 of us. I'm number 2. So thank you for coming, Mama. My husband, Phil Gerard, is also here. You will see he contributed significantly to this talk. He's a neurologist. So at the end, if you have any questions, ask him. Let's see, okay, so I guess I'll get going here. I have not read this, but one of my students said, just yesterday, he said, there's a book called My Stroke of Insight. I wish I had read this. Apparently, this is a woman who's a neuroanatomist, and she had a stroke, and she talked about what was happening as she was undergoing the stroke. So I'm looking forward. I went and got it yesterday when I should have been going over my talk. Anyway, I'm going to read that later. Okay, I'd like to begin with, guess I need my glasses. Stroke actually ranks as the 3rd leading cause of death worldwide. This is after heart attack, which is number 1, and cancer, which is number 2. So stroke ranks 3rd as the leading cause of death. It's interesting in that as far as a sex difference, 25% more men get strokes, but 60% more women die of strokes. And I thought that was interesting, and the reasoning apparently is because women live longer, so they get strokes later in life and they're more prone to die from them. By the way, just to, I'm going to divert a second and talk about cancer. It's the 2nd leading cause of death, and there are actually the 3 most common causes of cancer are lung cancer, then colon cancer, and then the 3rd leading cause of cancer, I'm just taking a little diversion, is breast cancer in women and prostate cancer in men. And so I'm going to kind of be suggesting healthful things to do. And by the way, I did eat my vegetables. Anyway, if you have to avoid getting lung cancer, don't smoke. Although some people that do get lung cancer don't smoke. To avoid getting colon cancer, get a colonoscopy. And then breast and prostate, get checkups. But now I'm going to go on with the stroke talk. Okay, the definition of stroke is anytime there's an interruption of the blood supply to an artery to the brain. What happens is if that blood supply is interrupted, the artery can get occluded or blocked, and then what happens is the tissue beyond or distal to that can die, and those are neurons. So beyond the obstruction, the tissue dies. And so again, if there is an interrupted plaque, or if the artery gets interrupted in any way, there can be death to tissue. And that's usually caused by something called ischemia, which is lack of oxygen to the tissue, And let me quickly explain what an artery is, because I know not everybody is a biology person in here. In the body, we have 3 different kinds of blood vessels. We have arteries that take blood away from the heart to all the tissues of the body. And I'm going to be referring in this talk to arteries that leave the heart and take oxygenated blood up to the brain. So those are the ones I'm going to zero in on. But an artery, by definition, is any blood vessel that carries blood away from the heart. In this case, it's going to be to the brain. Veins return blood to the heart. I'm not going to be talking about them. And capillaries are in between. That's where exchange with the tissues occurs. So an artery, again, leaves the heart. And in this case, I'm going to be talking about carrying blood to the brain. Some people refer to another type of stroke. It's called a hemorrhagic, or neurologists and neurosurgeon call this an intracranial hemorrhage. That's actually not considered a true stroke, so I'm not going to talk about that type of stroke during this talk. I'm going to be zeroing in on, again, ischemic stroke, in which there's a blockage to an artery and therefore tissue dies. Sometimes people mix up what a stroke is, and again, I'm going to say it the 3rd time. An artery gets blocked, nervous tissue dies. Some people think a heart attack is a stroke. Heart attack is not a stroke. It's actually some of the same risk factors are involved, but in a heart attack, there's a blockage in an artery to the heart. In a stroke, it's a blockage of an artery to the brain. And some people mix up seizures with strokes. What a seizure is interruption of the electrical activity going through the brain. So stroke is not a seizure. And the last thing that people mix up sometimes is they think of a blockage of blood flow to the whole brain. For instance, that might occur in a cardiac arrest, and that's not a stroke either. A stroke is actually a specific part of the brain that gets damaged. And what happens is if a small blood vessel is blocked, it creates a small stroke, and you guys can figure this out. If a large blood vessel is blocked, it creates a larger stroke and more tissue is affected. Okay. I think what I'll do is, Eric, did you pass around that handout? Yeah, I don't know if you guys want to take notes. You don't have to. That was my husband's idea. Anyway, on the first page, you'll see that there are 3 major causes of stroke. If you look up at the top, one is due to atherosclerosis. They used to say arterial sclerosis. That term's not used anymore. Atherosclerosis is commonly thought of as hardening of the arteries, and I'm going to talk about that in a little bit. Something called plaque can build up in the arteries to block them. So that's one cause of stroke is due to atherosclerosis. A second cause is due to an embolism. And an embolus is something that floats around in the blood. It actually could be gas or it could be actually cells. In this case, to produce a stroke, it's usually a blood clot. It's most often a blood clot. And quite often the embolus comes from the heart. And this is due to the fact that some person may have heart disease. And I hope I don't throw you under the bus on this one, Mama. My mother has atrial fibrillation. She has an enlarged left atrium. And what that does is the atrium doesn't contract as a unit, and it kind of wiggles instead of contracting. And so people with that kind of a situation can sometimes develop emboli or blood clots. And in my mom's case, it came loose and it went to her brain, but it didn't affect her thought processes at all. In fact, her memory is 5 times better than mine. And so it just affected her balance a little bit. So she's in a wheelchair, not because she can't walk, because she sure can, but she's actually just a little bit off balance. So thank you for letting me share, Mama. Okay, so in the third cause, if you look at that list, the third cause of stroke is due to hypertensive small vessel disease. Hypertensive small vessel disease. What that is it affects small arteries in the brain, and the primary cause of that is hypertension or high blood pressure. Hypertension or high blood pressure. And this type usually is not fatal. It affects a very small part of the brain usually. Okay, I am going to begin by talking, I hope I don't mess this up. I'm going to begin by talking about atherosclerosis. So that's one of the 3 major causes of stroke. Okay, and I've got this picture behind me that's dedicated to Shelley. Okay, and Kathy. Anyway, atherosclerosis, generally in atherosclerosis, plaque forms inside arteries. And what plaque is, people call that hardening of the arteries. It's generally a lipid core surrounded by some connective tissue covering, and the plaque forms on the inside of the artery and protrudes into the center of the artery. That center area is called the lumen. And over time, that can get harder. I'll go into more detail, but over time, that can get hard. It can crack. And what can happen is with the lipid core, what happens is it develops a connective tissue covering, and over time that can actually get harder and harder. A fissure or a crack can form, and then a blood clot can form on top of that, and that leads to occlusion of the artery. I'll go into a little more detail right now, though. Okay, generally damage, in the case of atherosclerosis, damage occurs to the inside of the blood vessel, and that's called the intima. The blood is flowing, and that's the layer right next to the blood. And what occurs, it can happen in places where the artery is bifurcating or splitting. So what happens is damage can occur, and this can be due to somebody smoking for a lot of their life. It can be due to diabetes. It can be due to other reasons. But damage occurs at some of the branch points of the artery. Then what happens is to that location that's already damaged, certain white blood cells migrate. And there are these white blood cells called monocytes. And they migrate to the area. And there are other lymphocytes. Those of you that may know that term, those are different white blood cells. Those can migrate to the area too. Monocytes are cells that once they leave the blood and they come into an area in which there's damage, they can turn into something called a macrophage. And that means big eater. And this generally happens during times of inflammation. And let me back up and say that your body undergoes an inflammatory response anytime there's tissue damage. So let's say there are chemicals involved, and I'm not going to bore you with those also. I don't know them. But anyway, there are chemicals involved. I'll refer you to Lynn Mizuno and Joe Beeman for that. There are chemicals involved. But anyway, macrophages in the area, they ingest lipids that are floating by in the bloodstream. They ingest the lipids. And then they move to the core. And so what they are is they're white blood cells that have ingested the lipids. And this is an attempt to protect the body, and this tends to be people that have high cholesterol in their blood already. So the macrophages actually ingest the lipids. Then smooth muscle cells migrate. Some of you may know that arteries have 3 layers. I'm going to tell you about it if you don't. So arteries have 3 layers. They have the inside layer next to blood. They have a smooth muscle layer and then a connective tissue layer. So the middle layer is smooth muscle, and that helps the artery to regulate blood flow. By contracting, less blood goes to an organ, dilating more. So what I'm saying is that in the artery there are already smooth muscle cells, and what happens is these smooth muscle cells migrate to the intima, which is the inside layer. And this does not happen in any other place in the body. Usually smooth muscle cells contract, which means shorten. But here in this situation, the smooth muscle cells make connective tissue, which is the hard, it's in your hair. It's actually, that's keratin. Connective tissue actually makes up cartilage and bone in your body. So what these smooth muscle cells do, they don't do it anywhere else. They normally contract, but here they make connective tissue fibers. And that ends up forming a kind of tough covering for the macrophages that have ingested the lipid already. So we got this thing, and what this thing now is, it's called an atheroma, and that's why they call it atherosclerosis. And that bulges into the lumen, which would be the inside of the blood vessel. And as I mentioned earlier, over time, the scar tissue replaces the living cells, and it turns hard. Cells inside die, and then because it's hard, these cracks can form. And on top of the crack, platelets are drawn to the area. And some of you know that platelets cause blood clotting. So platelets are drawn to this area, and then what happens is fibers in the blood form a blood clot, and blood coagulates in that area. So this blood clot forms on top of the platelets, which have been attracted to that rough, hard atheroma. Then what happens is the blood clot occludes the vessel and potentially can block blood flowing to the brain, and that creates a stroke. Okay, so that's atherosclerosis. Let me move on to embolism. So the second major cause of stroke is due to an embolism, and that is generally a blood clot coming from the heart. And as I mentioned in my mother's case, it can come from somebody that has atrial fibrillation, which is an abnormal movement of the atrium. It can also come from people that have had a previous heart attack, which is scientifically called a myocardial infarction, or an MI. And those can actually increase somebody's chances of having an embolus floating through the blood. Also, someone that has heart valve disease is more prone to having a blood clot move from their heart up to the brain. Third reason for stroke is hypertensive small vessel disease. Sometimes that is called a lacunar stroke. I don't know if you guys have ever heard of that. Lacuna means lake. It forms little pools. At any rate, this only occurs in small arteries of the brain. This can actually take years to develop, and it can actually begin in childhood and then get worse with time. But what happens is the high blood pressure causes damage to the small arteries, and they don't have thickened walls like the large arteries do, so they can be easily damaged, and a blood clot can form on them also. So the blood clot forms in both cases. One reason to treat high blood pressure early is, so for instance, let's say you haven't had your blood pressure taken in a long time. I would suggest you get your blood pressure taken because a lot of these people have high blood pressure. They don't know it. They have no idea what their blood pressure is, and then they get a stroke. And by the time they get the stroke, it's too late. So keep, sit down there in your, CVS, where I always think old people do that. And then I sat down the other day and I had my blood pressure. Well, I am old, I have to admit. So anyway, I'm one of those. Oh, no. Okay, so anyway, guys, get your blood pressure taken because that could prevent, you could get it, you could take medicine for it. Okay, now what am I going to do? What I'm going to do is move on to the next picture. The symptoms of a stroke are what people show up with. The lady in this book, let's see if I can find it. I was just glancing through this book this morning. Symptoms mean what people show. The lady in this book, I just actually opened this morning, says warning signs of stroke. S, it's going to end up spelling S-T-R-O-K-E. Okay, S, speech or any problems with language. T, tingling or any numbness in the body. R, remember. A lot of people have memory problems after they've had a stroke. O, off balance, problems with coordination. K, killer headache. It doesn't always appear, but sometimes it appears. Probably you guys will all walk out of here with headaches. Huh? E, eyes, any problem with vision. Okay, anyway, what I'm going to do is the symptoms of stroke have to do with the part of the brain that's damaged. And now this is what I normally lecture on in class. In fact, I just gave a brain lecture this week. So I'm going to go to the next slide. And what I'd like to do here is I'd like to explain parts of the brain, and then I'll explain blood vessels that go to those parts, and then I'll try to explain that if something blocks the blood vessel, what we can't do anymore. So now I'm not nervous. This is my deal now. No. Yes, Brett.
Before you get that,
Sure.
You said there was some ways to keep from getting a stroke. And
Yes.
The first one there was the arthrosclerosis, and they have drugs for that. There's like Lipitor.
Yes.
And
Yeah.
You mentioned lipids. Do each one of these drugs have a name associated with the things that they're trying to battle to keep you from?
Sometimes they have their own brand name. Yeah, but I'll get to Lipitor. Yeah,
Okay.
that one does prevent an enzyme from causing cholesterol formation. So it prevents cholesterol formation. That one.
Okay.
But yeah, not all of them are named after what they do, though.
Okay, you're going to talk about how we could avoid.
Yes.
Okay.
Yeah.
Okay.
Yeah, we can't, yeah, I will.
Okay.
Risk factors, yeah, I'm going to get to risk factors. Okay, all right, the brain is divided into what are called lobes, and that's generally done by these wrinkles on the brain and these creases. Every wrinkle on the brain is known as a gyrus. So like, you guys see that green one right there. So that one is called if you see the little arrow, it's called the primary motor cortex. Another name for it is precentral gyrus. So what I'm telling you is each one of those bumps is a gyrus. The crease in between, like right there, that little crease in between is known as a sulcus. So all of us pretty much have the same basic look to our brain. So we all have a central sulcus, and what anatomists have done is that has separated this whole section of the brain called the frontal lobe. Can I walk over this way, Scott? Yeah, I don't like to keep my back to people. Yeah, so that actually separates the frontal lobe in the front, and that's going to be behind your frontal bones. Then behind the central sulcus is a lobe called the parietal lobe, and it's under two bones here called parietal bones. Way at the back, some of that went off. That's called the occipital lobe, and that's because it's inside this bone called the occipital bone. Temporal lobe is here, and that is inside two bones here. Oh, and just so you know how this works, this would be, in my head, this would be called the left hemisphere. So in other words, you would be looking at half of my brain, and the person's eye would be here. So this is the front of the brain. In anatomy, that's called anterior. This is the back of the brain, and that's called posterior. So you're looking at what's called a lateral view of the left hemisphere. So because of these gyri and sulci, it divides the brain into a frontal lobe, parietal lobe, occipital lobe, temporal lobe. In this crease is one I won't really talk about. It's called the insula. It's called the insula. Then that's all the higher intellectual functioning, especially the frontal lobe. So all of us are much smarter than gorillas and chimpanzees, and I hope so, huh? And anyway, and it's due primarily to the frontal lobe. Some of these other things, that's called the cerebellum. I will be talking about that. The cerebellum is real important in coordination and keeping your balance. And then there's something under there called the medulla and the pons. They're part of the brainstem. And at the very bottom is the spinal cord that relays information up and down. Okay, let me start kind of lobe by lobe and give you guys some ideas of what each lobe does, although it's much more complicated than what I'm going to say. And they've discovered all this either because of strokes or, heaven forbid, shrapnel in war injuries and just terrible things like that. But they've discovered that certain parts have certain functions. So I'm going to be simplifying them down. This prefrontal area of the frontal lobe is, again, where higher intellectual functioning is done. So like Mozart in his composing, or Bach in his composing, or, pick a wonderful artist, Monet. You math people are really good in there. So anyway, I'm not a math person. I'm lousy in there. At any rate, so that's all the higher. It's also got drive and ambition and computing and analysis. And memory is actually done by the whole brain, but a lot of memory is done in the temporal lobe. Okay, let me pick out a couple of specific areas. By the way, let me do this dark green. This primary motor area is the part of your brain where commands come from to cause all of your skeletal muscles to contract. And I need to tell you guys, you have 3 kinds of muscle in the body. You have the skeletal, I've got a puny biceps, but anyway, this biceps muscle is called a skeletal muscle. You have control over it. We also have cardiac muscle in our heart, and we have smooth muscle like in our stomach and our bladders. This part of the brain actually will give commands to all the skeletal muscle of your body. So, and the way this works, I'm going to go to the next one. It's kind of an ugly guy laying here, but anyway, this, if you guys will look at this picture over here, his face went off. That's okay. There's supposed to be a face over here that looks similar to this face. This is supposed to show you a map of which parts of that gyrus regulate which parts of the muscle in your body. So his face is supposed to be here. So a large part of this motor cortex moves the muscles of your face. Large part of the motor cortex moves the muscles of your hand because we have a lot of dexterity. Not so much is devoted to the rest of the body. And what happens is if there is a blood vessel that affects this part, it might affect a muscle to your face. If there's a blockage of, let's say, a blood vessel to this part of the brain, it may affect the operation of your hand and so on. So there's a map. There is a map, and I'm going to go back down to this. So that thing's called a homunculus. It means little man. And so it would be like the face is down here and the rest of the body's up here. So if there would be a stroke, let's say, in this area, it might affect the muscles of the face and so on up there. Okay, and then in front of this area is called the premotor area. This is devoted to, they call it complex learned tasks, like writing your name or texting. I'm not so good at that, so that part is, so anyway, texting, let's say, or let's say using your computer. So if something would happen to this part of your brain, maybe you wouldn't be able to write your name the same way anymore, or you wouldn't be able to text your buddies, or you wouldn't be able to use the keyboard so well. So that's complex motor actions there. This is a special area called the motor speech area. A neuroanatomist, Broca, discovered it. In this particular area, and it's only on the left side of the brain. It's interesting. It's only on the left side of the brain. This gives commands to part of the motor cortex that is involved with the muscles of speech. So I'll say that again, because it took me a long time to figure that out. This part of your brain gives the motor cortex commands to move the muscles of speech. Okay, what are those? It'd be like muscles of your lips and muscles of your tongue and muscles of your vocal cords. And it even tells your hand how to write your name. So let's say somebody gets a stroke there. It's in an artery that comes the outside of the brain called the middle cerebral artery. If a part of the middle cerebral artery gets a stroke and it affects that part of the brain, the person would be completely intelligent and they would know what they want to say, but they wouldn't be able to say it because the command is not going to the speech muscles. So they would be doing something like, and it doesn't affect their intelligence, it's affect the command to the speech muscle, or they wouldn't be able to write their name. So that would be a stroke there. It's kind of depressing, huh? Anyway, let's go to the parietal lobe. This particular gyrus back here has a couple of names. It can be called the sensory cortex, somaesthetic cortex. I think on your outline I've got somatosensory cortex. In this part of the brain, you're actually receiving, and again, this is part of the parietal lobe, you're receiving signals which are sensory. And sensory means incoming signals, but they're not the big senses. It's not sight or hearing. It's things like temperature and pressure and taste is here. And those kind of things are fed into this part of your brain. And I'm going to go to the next one. And it's very similar. It's very similar. This is supposed to be the map of the motor part of your brain. This is the map of the sensory part. So in other words, it's another man upside, or woman upside down, and a lot of your sensory part is devoted to your face, and a lot is devoted to the hand and not so much to the rest of the body. So in other words, a stroke here would affect how you feel, pressure in your face. A stroke here might affect, feeling or pain in your fingers, and so on. So the part of the body is expressed. Oh no, and I didn't tell you this. I'll go back to this one. Your left motor cortex commands the muscles on the right side of your body. Probably you guys have heard that. If somebody has a left motor cortex stroke, they're paralyzed on the right side of the body. What happens is the neurons come down from the motor cortex and they cross over to the opposite side at the bottom of the brain called the medulla. So what I'm saying is, like, this side of my brain, the neurons are nerve cells, neurons are coming down, they cross over to the other side at the medulla, and so they're going to be regulating muscle on this side. And I saw a neuroanatomist speak once, a woman, and this is going to look kind of stupid, but I don't know you, but this motor cortex regulates this arm. So let's say I come over to her and I pound her. This is supposed to be related to war and fighting, and I pound her in the head over here. Because this side regulates this arm, she can still sock me in the face. That may be far out, but anyway, I saw a neuroanatomist that said she thinks it's related to survival and fighting. I have no idea. I'll have to ask my husband later. Okay, anyway, the same thing on the sensory cortex. Same thing on the sensory cortex. What you feel with your left hand gets fed into the right sensory cortex. Okay, so if something happens to blood vessels here, you may not be able to feel pain or temperature. This is kind of interesting back here. Well, I think so. Sorry if you guys are falling asleep. But anyway, yeah, back here is a sensory association area. And what that does, that makes sense out of what you feel. So let's say I've got this mic that I feel right here, and I know it's right here. And I don't have to look at it, and I know that it's right here. If something were to happen to that part, which is called the sensory association area, I would feel this little box, but I wouldn't know what it was. Whereas right now, without feeling, I know where it is. Scott gave it to me, so I know, okay, I got to keep this here. Or like you have keys in your pocket. Let's say you have keys in your pocket. You can feel the keys in your pocket and you know they're keys. Well, if something happens to that part of the brain, you would have to pull the keys out of your pocket and look at them to know they were keys, if you guys understand. Yeah, so it allows you to know the feeling of things. But if that goes, you have to use your eyes. You don't know what it feels like. Back here, this is your visual area. This is where you see images. So if you get a stroke in this area, you can't see. But I need to tell you that you guys obviously know your eyes are out here. Your visual area is back here. So the pathway for vision goes all the way through your brain. So actually, you can have damage to your sight from the eyeball through the temporal and the parietal lobes all the way back to the occipital lobe. If you have a stroke all the way through there, you could have problems with vision. So that's one that kind of projects all the way back. Right here is something called the visual association area, and that's making sense out of, like I'm looking at Brett right now, and I know he's a teacher, and I know he's a good teacher. And anyway, so I'm looking at Brett. Okay, that's Brett. Okay, let's say I get a stroke here. I shouldn't say that. Let's say somebody gets, I don't want to bring it on. It would be your guys' fault. Anyway, let's say somebody gets a stroke here. I would see Brett, and I have no idea who he is. I'm looking at him, he's sitting there, and this is kind of sad, like you go to visit your family member in the hospital, they don't recognize you anyway. They see you, you're standing right there, but they don't recognize you, so that would be damage there. Okay, this is an interesting area. Wernicke's area, it's kind of gone off there, but it's in the picture. Wernicke's area is another speech area, and that area kind of starts in the lower parietal lobe and kind of swings down to part of the temporal lobe. If you have damage or if you get a stroke there, you don't know the meanings of words. You do not know them. So I could lift these things up, and I have no idea what these things are for. I'm looking at them. I don't know what they're for. And you also can't speak. If someone says talk, you'd say ceiling, fairy, chair, I don't know. Anyway, it comes out like word salad. It makes no sense at all. So in this part of your brain, it's making sense out of words. So you guys know this is a book, and you guys know these are glasses. Well, those people don't know what those things are for, and they can't speak also, and they don't understand. So that takes away comprehension of spoken and written word if you get a stroke there. I better get going. Right here is the primary auditory area, so that's where you receive sound. So if something happens there, you can't hear. Under it is the auditory association area, and that helps you know the difference between like a siren and a trumpet. So if something happens there, the person hears noise, but they have no idea how it relates to their life. Changes in mental status. Stroke in this area, I told you this is where you have higher intellectual function. Stroke in this area here can obviously affect maybe your personality. I was getting my gray colored the other day, and the lady that does that said her grandma had a stroke, and after the stroke, she was terrible to live with. Nobody wanted to take her. Let's say they went to Houston's restaurant in Pasadena. She says, it's too dark in here. And they sit down. I can't read the menu. And none of this food tastes good. And after a while, people didn't want to take her anywhere. So this can cause personality changes. It can also show up as confusion when the person first has a stroke, confusion. It can also disorientation. They don't know where they are. And then, and one more in here. The temporal lobe is big on memory, and quite frequently people show up if they have a temporal lobe stroke with memory loss. Oh, and one interesting thing that I think is interesting is in the parietal lobe, there's something that tells you where your body is in space, tells you where your body is in space. And in this area, there's something called hemi-neglect, whereas a person that has, let's say, a right parietal lobe stroke, they don't recognize their left arm and their left leg. And the doctor can lift and say, whose arm is this? And they say, that's not my arm. And they get in bed. What's that getting in bed with me for? That sounds kind of odd, does it? Anyway, I can make a joke, Steve, but I won't. I'll leave it to Steve. He's always doing that to me. Anyway, so yeah, let me go to the next one. Steve is always doing that to me. Oh boy, I'm talking more than I thought I would. Okay, let me go through a few blood vessels, and then I'll talk about the medical part. The blood vessels that feed your brain, the heart is cut away from this picture. It's down here. This big artery, brachiocephalic, brings blood away from the heart. This artery is a big artery furnishing blood to your brain. It's called the internal carotid artery. Internal carotid. This little place here is called the carotid bifurcation. It means split. Sometimes plaques form here, and they can actually move by emboli up into the brain. And then this artery is the vertebral artery or vertebral artery. That's also a big one carrying blood to the brain. I'll go to the next one. The vertebral artery, I don't know if you guys know that. Let me go back. This one you're going to see different in this next picture. So imagine this one going up. Those are called your cervical vertebrae. That goes through a big hole at the bottom of your skull called the foramen magnum. And then what happens, these are the two vertebral arteries. They form something called a basilar artery. The basilar artery furnishes blood, among other things, to your cerebellum and your brainstem, which is like the part of your brain that this sits on. And if there is a stroke on this basilar artery or the vertebral arteries, it can affect basic life functions like breathing and heart rate and so on. So a basilar artery stroke is real bad, as are vertebral. And what I'm going to show you here is these vertebral arteries and basilar arteries feed into something called the circle of Willis, which is a circle around the base of your brain. That little organ right there is the pituitary. And these arteries come off the circle of Willis and furnish your brain. And I'll just go on. I'll just mention these arteries quickly here. Again, this is the vertebral artery forming the base, or this is the circle of Willis. Some of you might see this artery coming out to the side. That's called the middle cerebral artery. That would affect your language areas and your frontal lobe, your parietal lobe. That affects a lot of your language area. Did I tell you guys that the language area is only on the left? Language is only on the left. On the right side, in those same areas like Broca's and Wernicke's, is like visual and spatial, and it conveys language. How do I say this? It conveys some things like tone of voice and facial expression. So in other words, let's say, do you have kids, Roger? Yeah. 4? Oh, brother. Are they teenagers?
2 of them.
2 of them, okay. Let's say Roger is telling one of his teenagers, you're not going out tonight. You left the car without any gas. So anyway, the left side of his brain, of that kid's brain, you have a son? Okay, let's say his son's brain says, my dad just told me I can't go out tonight. Well, the right side of his son's brain would say, wow, his tone of voice was kind of mean, and he had his hands on his hip, and his body language was, so this side is more the affect, and this side is, but when people say right brain, left brain person, that's kind of oversimplified. You know, I'm a right brain person because I'm creative. I'm a left brain person because I love math. That's actually not really true. I mean, it doesn't have a scientific basis. But on the language, this is more analytical, and this like puts sentence structures together, and this is more the effects of body language and that sort of thing. Okay, I think I covered this. Neurologic symptoms. This is a lot to read, guys, but I'll just kind of whip through this. Confusion, poor memory, this may happen. All of this may happen actually in the frontal lobe. Hemi-neglect, that's not my arm. That could be parietal lobe. Memory deficits, temporal lobe. Wernicke's aphasia. That word aphasia means inability to come out with. You guys remember Wernicke is the area that helps you understand words. If somebody has Wernicke aphasia, they cannot put words together that make any sense. Sense of smell. I think I talked to this. Okay, this is actually a picture of the brain, and I just wanted to show you. This is the cerebral cortex, cerebellum. This is the part that's called the brainstem. This part here is called the brainstem. And I want to go to the next slide. And these type of symptoms would be problems with, you know what, I think I redid the slide and then it came out a different slide. Oh, Yeah. Anyway, some of these symptoms are brainstem functions that have gone bad. Let's say altered taste or hearing. This would be, some of my students, that would be the auditory nerve right there. Drooping of eyelid. This would be a nerve, I'll do this fast, guys, called the oculomotor nerve. Decreased reflexes, gag, swallow, pupil reactivity. I won't go through all this, but these are brainstem problems, and possibly the vertebral or the basilar artery is involved. Balance is the cerebellum. Breathing and heart rate would be also brainstem. Does anybody know where the sternocleidomastoid is? It's this neck muscle, yeah, right here. That would be also problems, and you aren't able to turn your head to the side. Weakness in the tongue and the ability to move it, slurred speech. Okay, let me go on from this. What the physician does after all that anatomy is when the physician examines the patient, they get the, they come to their diagnosis with examining the patient, looking in the pupils and measuring all the reflexes and so on. But if they want confirmation of their diagnosis, they order a CT scan. And what the CT scan shows is, it actually is ordered to rule out a hemorrhagic stroke because quite often those are normal in that ischemic stroke. So it's to rule out a hemorrhagic stroke. And if they want more exact, like exactly where the stroke is as far as its size, location, and severity, the doctor will order an MRI. And so this shows even more precise location of where the stroke is. And then sometimes an angiogram can be ordered. What they do is they put a catheter in the femoral artery and they thread it up and they put dye in there and they can see where the artery is occluded. Treatment of stroke. Let's see if I said all of it. I was going to say, I'll get close to this. Okay, sorry, this went off the edge here. One purpose is to limit or reverse the brain damage the patient is experiencing. So TPA is tissue plasminogen activator. It breaks down blood clots. Its job is to break down blood clots, and that's so that the blood clot doesn't get any bigger. So it dissolves blood clots. This can only be given, TPA can only be given in the first 4.5 hours. So it's called the TPA window. So if you suspect somebody has a stroke, get them to the hospital and they need that TPA right away, because after 4.5 hours, tissues start to be real fragile and they bleed easily, and that can actually work against the patient after 4.5 hours. Aspirin treatment, that actually is important also, and the aspirin just prevents the blood clot from getting bigger. The other purpose is to prevent further strokes. Daily aspirin tablets, again, prevents blood clots from getting bigger. Control of hypertension, so go get that checked. You can take medication for hypertension or high blood pressure. Carotid endarterectomy. If somebody has a plaque in their carotid artery, that plaque can be surgically removed. Coumadin. I take my mom to Coumadin all the time. What that does is that prevents the blood from clotting, especially in her case, she doesn't want any blood clots from her heart to go to her brain and cause another stroke.
How does aspirin, again, help? Is it a thinner of the blood?
Yeah.
How to keep the clots from her?
I don't know. Ask him. Sorry, Brett. Statins and cholesterol-lowering drugs. This is the Lipitor thing, Brett, you were talking about. And that there's Lipitor somehow and I don't know how, somehow it prevents an enzyme from making cholesterol, from building up. So it prevents cholesterol, from being produced. Okay, now I'm going to go to risk factors. Old age, we can't do anything about that, so too late for that. Previous stroke, or you guys know TIA is transient ischemic attack. That means like a blood clot forms quickly. Blood clot forms, and then it goes away. The blood continues, it dissolves. Thank you. Yeah. So it's usually in a little blood vessel, and then it goes away. resolves. That's the word I was searching for. Hypertension, the most important modifiable risk factor. That's a big one. If you suspect you have high blood pressure, go ahead and get that checked, and you can take medication for them. Atrial fibrillation or heart valve disease, another risk factor. Don't smoke tobacco. That's bad. That can lead to all sorts of. That can lead to all. I have a big old list I give my class. It can cause lots of cancers, stroke, heart attack. Terrible, terrible for you. High blood cholesterol level. You can take medication for that. Diabetes. Actually, that's about it. So thank you very much, guys. If any of you have questions that I don't need to be a medical doctor for, I'd be happy to answer one or two. Otherwise, there's a man there that can answer the rest. Yes, Kathy.
A lot of the studies on using aspirin to lower risks have been conducted on males, and then when they go back and they conduct them on females, some of what I've read has said there are slightly different risk factors. Can you comment on that?
Do you want to take that one? I know it's not your time. I knew this would happen. I don't know, Kathy.
Okay.
Ask him later. Anything about the anatomy of the brain? Inger.
How does, my dad's had several TIAs. How does that differ from a full stroke?
Oh, okay. TIA means that there's up here, for less than 24 hours, the blood vessel is blocked, and then somehow it resolves. Maybe the little clot moves downstream, and the blood pushes it to a more open area. So it means that it resolves and it's not blocked anymore. But it increases your chance of having a big stroke. So they say a full-on stroke is anything that lasts more than 24 hours and does cause occlusion of the vessel and damage to a part of the brain.
TIA doesn't cause damage, or?
No. Yes, ma'am.
A friend of mine is about 56 years old. He had a stroke. He understands everything. He has a hard time. He has a hard time expressing himself and making the words out. Can he ever regain part of his ability to speak? Or
No. Yeah, if the neurons are dead. Yeah, there's something called the cell body, which has all the nucleus and the DNA in it, and when that's gone, neurons don't undergo mitosis, which is dividing, and so, yeah, he can't get it back. At the very onset of it, there's something called the inflammatory response, and at the very beginning, improvement happens, but after about, I don't know, a couple of months, if there's no improvement, they can actually do physical therapy that helps, but it doesn't bring back that part of the brain. Yeah. Yes, sir.
Is there a most common location for strokes? I mean, what or a most common area in the brain that's affected?
I know the basilar artery is affected a lot. That's that one that feeds in, and I know the middle cerebral artery on the side is affected a lot, and I know the vertebrals. So basilar vertebral, and not so much the anterior and posterior cerebral. So those, yeah, the vertebral, basilar, and middle cerebral. The one on the side and the two feeding in at the back. Those are common places. Yeah, Stuart?
If you get your heart valve replaced, does that usually take care of atrial fibrillation?
I don't know.
Is that medical?
I can look. I'll wiki it. I don't know, Stuart. I'll have to look that one up. Yes, ma'am.
I have a silly question, but I've always been curious. Do you ever watch Grey's Anatomy and say they're doing it all wrong?
You know,
Or
I wish I did. Yeah, I don't watch any of those. And I'm sorry. I like movies.
you ever watch movies and say they're doing it all wrong?
Yeah. Sometimes when I was in high school, I saw General Hospital, and they had the X-ray upside down. But anyway, thank you. Oh, one more question in the back.
Was your first language and second language being affected similarly by the same stroke?
Can I, if it's a memory problem, the second language is affected more, the first language holds longer. And the reason I can answer that is my grandmother. 100, she lost English.
Yeah.
She could still speak Portuguese. Yeah.
Interesting. Okay. Thank you, Kathy. Thank you, all of you, for coming. Yeah. It's over.